Yeah. Thank you. Yeah, guys. So as I said yesterday, we started like we discussed a little bit trig functions. I mean, I try to introduce the trig functions and try to define them. So I'm gonna remind you again, right? And we also talk about this the how we measure angles, right? We said that we can use radians or degrees, to measure angles, and we saw how to convert like radians to degrees and degrees to radians, etc. But so let me just remind you very quickly. So what we did yesterday. So we're gonna take a unit circle. So let's take a unit circle. So what do I mean by a unit circle? That's a circle of radius 1. A circle of radius 1, right? 1 unit. So I have my, I have my x-axis as usual. This is my x-axis, and this is supposed to be my y-axis. All right, and so this is let's say here's 1. Let's say this is 1 here. This is -1 right here, and there's -1 right here. All right. Now, so I'm gonna take the circle with the center, the origin. Natalie, you are here. Oh, okay, I got you. Thank you. Thank you. So we're gonna take the unit circle with the center, the origin, the 0. So here's my circle. This one here. All right. And then I'm gonna take an angle. Tiffany, yeah, I got you. Thank you, Tiffany. Yeah, thank you. And then I'm gonna take an angle theta. So here's my angle. So let's say this is my angle. So this is my angle theta. Okay. Now I'm gonna take the right triangle. I'm gonna take this right triangle. So here I'm gonna have like a right angle that's 90 degrees. Okay, this is a right angle here. Okay. And then so we have this point, guys, this point which corresponds to the angle theta, this point here. Okay. So this point, let's call the coordinates of this point. So the point of coordinates x and y. Okay. Which means that this is actually, here's x, and this is y. Okay, that's the point xy. Now in this right triangle, so here's my right triangle, the yellow one. Okay, this yellow triangle. So I'm gonna define. So I'm gonna just draw again the right triangle so you can see. So here's my 90 degrees, and here's my angle theta. All right. So we said yesterday we're gonna define the sine of theta. So this is the definition of sine of theta. So sine of theta would be equal to, so in this right triangle, we have this right triangle. So then sine of theta would be the opposite side to the angle theta over the hypotenuse. So what do I mean by opposite side of theta? That's so as you can see, this is my theta, this is my angle theta, and the opposite side would be this one here. So this is what I call the opposite side to the angle theta. Right? This is the opposite side to the angle theta. Okay. Now the hypotenuse. So what I call the hypotenuse is the opposite side to the right angle. Right. So so this is my right angle. So the opposite side is this one here. So that's my hypotenuse. Okay. So this side here, that's my hypotenuse. Okay. And now the third or the last side would be, that's the adjacent side, right? This one here, that's the adjacent side to the angle theta. Okay. All right, guys. So that's the definition of the sine of theta. Now, because remember, guys, we said this is a unit circle. So what's the length of the hypotenuse, right? This is my hypotenuse, right? This is the hypotenuse of my right triangle. So what's the length of this side, the hypotenuse? Well, it's because it's a unit circle, so the radius is 1, right? And the radius, guys, that's the distance from the center to any point on the circle, right? So this hypotenuse, I mean, the length of this hypotenuse is just 1, right? Because it's just the radius. It's the same thing as the radius, right? So the hypotenuse here, so the length of the hypotenuse is equal to 1. This is equal to 1 because it's just equal to the radius, and we are taking a unit circle, so the radius is 1 unit. All right. Now, what's the length of the opposite side? So the opposite side, of course, is this one here. Let me pick a different color. So you see, this is my opposite side, right? That's the opposite side to the angle theta. What's the length of this opposite side? Well, I mean, you can see, guys, this is exactly the same thing as this segment here, right? Both are the same thing. I mean, the length is the same, right? They have the same length. And the length of this segment, I mean, it's just given by y, right? Because again, we have this point, remember we had this point xy. This is the point xy. So the x coordinate, of course, is x, the y coordinate is y. And so the length of your opposite side is exactly the height or the level y, right? So this is just equal to y here. Okay. So the opposite side, the length of the opposite side is actually y. So again, y, that's the y coordinate of your angle theta, right? This is your point xy, which corresponds to the angle theta, right? So then, actually, sine of theta is just equal to. So then, sine of theta is just equal. So the opposite side, we said it's the y, the y coordinate of the angle over the hypotenuse, and because the hypotenuse is 1, so that's actually y over 1, which is equal to y. Okay. So what we are saying here, guys, is that so if you take a right triangle with hypotenuse equal to 1, then sine of theta, you can think of sine of theta as y, as the y coordinate of the angle. Okay, so you think of the sine of theta as the y coordinate of the angle theta. Now, what about cosine? Cosine is, so definition of cosine. So by definition, cosine is supposed to be the adjacent side the length of the adjacent side over the hypotenuse. Okay. Now, what's the length of the adjacent side? So the adjacent side is this one here, this side here, right? And what's the length of this side? Well, the length of this side is supposed to be like equal to x, right? The x, that's the x coordinate of my angle theta, right? This is my x, which is the x coordinate of the angle theta. Okay, so then so the length of the adjacent side is equal to x. So this is equal actually to x, and again over the hypotenuse, which is 1, because again it's a unit circle, the hypotenuse is 1, so that's x over 1, that's equal to x. So you need to think of you should think of cosine of theta as the x coordinate of your angle. Okay, so so what I'm saying, guys, is that you know, if you have like you have your x-axis, y-axis, and you have some angle here. This is your angle theta. This is all right. So let's say this is your angle theta here. Okay. So this angle theta corresponds to a point, this one here. You see this point here? Okay, so when you have your angle theta, so you have some point. Again, here we are taking the unit circle. So this is supposed to be equal to 1. This segment here, the length of this segment is supposed to be equal to 1. Then, so what I'm saying is that cosine of theta would be just the x of this point. So x here, the x coordinate of this point, that's the cosine of theta. And sine of theta would be the y coordinate of that point. So the y coordinate of that point, that's your sine of theta. Okay. And this is really important, actually. Later we'll see when we discuss the sign of when cosine is positive or negative, when sine is positive or negative. So you'll see why this is actually useful when you think of cosine as x coordinate and the sine as the y coordinate of the angle. All right, guys. Now, of course, now we have this. You know, we have this right triangle, and in the right triangle, of course, we can apply the Pythagorean theorem, right? So we have again this right triangle. I have my angle theta. So here's my angle theta, right? And so what we are saying is that so this is so the hypotenuse here is equal to the length of the hypotenuse is 1. This is 1 here. Okay. So the opposite side, we said that will be sine of theta. So this is sine of theta. All right. And the adjacent side, that's the cosine of theta. Okay. So that's what we are saying. We have a right triangle. The hypotenuse is 1. Okay. Then the opposite side of theta would be sine, and the adjacent side of theta would be cosine. Now, because of, as I said, Pythagorean theorem, so if we apply, apply Pythagorean theorem, which is, of course, whenever you have like, just to remind you, Pythagorean theorem, so you have like, a right triangle, one side is A, the other side is B, and the hypotenuse is C. So then, as you know, you have a squared plus b squared equal to c squared, right? That's the Pythagorean theorem.
Professor, is that a 1?
Yes. The purple here?
Yeah. Is it
that's 1. Yeah, the length. Yeah, the length of the hypotenuse there is supposed to be equal to 1 unit. Yes. Yeah, that's 1.
Mm-hmm.
Yeah, so now if we apply a Pythagorean theorem to this right triangle, then so this is like, here's my A, and this is like my B, right? And this is like my C. Yes, absolutely, Rabiul. So then, so if you apply Pythagorean theorem, then we have A squared. That's cosine square. So cosine of theta square plus B square. So that will be sine of theta square equal to C square. C is the length of the hypotenuse, and that's equal to 1 unit. So that's 1 square, which is 1, right? So this is like the most important trig identity. So cosine square plus sine square is always equal to 1. Of course, cosine and sine of the same angle, right? Cosine of theta square plus sine of theta square is equal to 1. Okay, for any angle theta, it doesn't matter the angle. All right, so this is our first trig identity, and the main. I mean, I would say the most important trig identity. Yes, Elizabeth. Yes, Elizabeth. You raised your hand, I think.
Oh, sorry. I thought I removed my mute.
Oh, okay. Oh, okay.
Because
No problem.
cosine is always with sine, right?
Cosine is what? Sorry, I didn't hear you.
Because cosine is the same, like, secant, cosine, tan.
No, we didn't define. We
This
didn't
is
define.
different.
No, the different tangent. You mean tan of theta? Tangent of theta. We didn't define yet the tangent of theta.
Oh, okay.
Okay. So that's actually that's a good point, because that's the next thing we're gonna do.
Because I know that, for example, if you select cosine and then you're supposed to take like cosine or something, right?
Yeah. So yeah. So for definition of tangent, tangent of theta, by definition, tangent of the angle theta, that's by definition sine of theta over cosine of theta. Right. There is also cotangent. Cotangent of theta, and that will be the reciprocal of tangent. So it's just cosine of theta over sine of theta. Okay. There is also secant of theta. Secant of theta, that's actually by definition, it's 1 over cosine. And there is a cosecant of theta, and that will be 1 over sine. Okay. Yeah, I guess that's what you mean, Elizabeth, right?
Yes, I remember that part.
But I mean, this is just the definitions here for. This is. If you know how to compute the cosine and sine, you're gonna be able to compute tan and cotangent, of course, secant or cosecant, right? So the next thing to do, of course, is we're gonna try to find the cosine and sine of some special angles. Yeah, let's do that. So next, so let's compute next. So let's compute cosine of theta and sine of theta for some special angles. As I said here, special angles, not all the angles, but some special angles between 0 and 90 degrees. Or in other words, between, so if we use the radians, between 0 and pi over 2. Right? Again, guys, just remind you, pi, pi is actually 180 degrees, right? So just to remind you here, pi, that's 180 degrees. Okay. All right. So for example, I mean, very, very simple example. I mean, I won't, of course, I won't compute all the angles, the sine and cosine of all the angles here. I'm going to show you how it works, right? So example, very basic example. Let's say you want to compute cosine of the angle 0. Okay. I mean, this is very, very, very basic and naive question, right? What would be, for example, cosine of the angle 0? Of course, guys, here, be careful. I mean, cosine, this is not like cosine times 0. This is cosine of the angle 0. You cannot separate the cosine of the angle. It's cosine of something, right? It's not cosine times 0. I'm not saying it's cosine times 0. So then that would be equal to 0, right? This is not multiplication, right? It's not like cosine times 0. Cosine of something, right? Cosine of some angle. That would be some number. Okay, so it's not multiplication here. It's not cosine times 0. So you cannot separate the cosine from the 0. All right. So I want to find. So of course this is not a dot here. That's cosine of. Cosine of, because by experience, from my experience, guys, I know some of you, I mean, sometimes they get confused, they think that cosine of 0, it's like cosine times 0 or cosine times, I don't know, some angle. So this is cosine of the angle 0. Anyway, so how do we do that? Well, the idea is very simple. I'm going to use my right triangle. Remember my right triangle? So in my right triangle, I'm supposed to have a right triangle here. This hypotenuse should be equal to 1. I mean, the length of the hypotenuse should be equal to 1, right? My angle theta, let's say here, right? And then the length of this side, that's cosine of theta, and the length of the other side, that's the sine of theta. All right. Now, if my angle theta is 0, okay, so what do I mean by angle 0? Remember, guys, yesterday we discussed this. We said that the angle is 0 when the initial side coincide with the terminal side, right? So what do I mean by terminal initial side? So you have like, you have the two sides. This is like the initial side, and this is your terminal side. So then the angle, so if you go from the initial side to the terminal side, that will be your angle theta, right? That's my angle. You go from the initial to the terminal side, that's your angle theta, right? Now, when you say the angle is 0, it means that the terminal side would coincide with the initial side. They are the same thing, just the same, the same segment or the same arrow, right? So,
Professor, terminal meaning ending?
Yeah, ending, yeah. Terminal mean ending, yes.
Thank
Mhm.
you.
So it's like I'm gonna have like this is supposed to be my initial side. All right. And then so you can see here, guys, so theta, this is my initial side, and this is my terminal side, which is the hypotenuse, right? And so what I'm saying here is that like the hypotenuse and the initial side, they're gonna coincide. Okay, so the initial side and the hypotenuse, so this is supposed to be the hypotenuse, they gonna coincide. So this is the yellow arrow, that's my, or the yellow side, that's my, or the yellow segment, that's my hypotenuse. Okay. So the hypotenuse here, the hypotenuse coincides with the initial side, coincides. All right. But remember, guys, the length of the initial side, you can see here, the length of this side, that's my cosine of theta, right? Now, in my right triangle, the hypotenuse is supposed to be equal to 1, right? This is, as you can see here, the length of the hypotenuse is equal to 1, right? So this hypotenuse is equal to 1 unit. The length of this hypotenuse is one unit, right? So if the hypotenuse coincides with the initial side, and the hypotenuse is the length of the hypotenuse is 1, then the initial side is also the length of the initial side is also equal to 1, right? So the initial side, or the length of the initial side is also equal to 1. It's equal to 1. Okay, because that's equal to the hypotenuse. And so what will be cosine of 0? Cosine of theta, that's supposed to be the length of the initial side, right? And that will be equal to 1, right? Because it coincides with the hypotenuse. So conclusion here is that cosine of 0, and cosine of the 0 degrees is equal to 1. Okay. Is there any question, guys, how I got this cosine of 0 equal to 1? I mean, this is important. I mean, of course, later we're gonna see more angles, but I mean, if you, I mean, it's really important that you know how to, you know, have like the idea how to compute cosine and sine. You don't get it, Lord? Yeah. So, again, the idea is you take. Same, okay, okay. So the idea is you take, so how do you compute sine and cosine? You take a right triangle, okay? In the right triangle, the hypotenuse is supposed to be equal to 1. The length of the hypotenuse is supposed to be equal to 1, all right? And then you have your angle theta, and then here's your angle theta, this angle here, all right? And so then the cosine of this angle theta, that's the length of the adjacent side, and the sine of theta, that's the length of the opposite side. Okay. Does this make sense to you guys? Just take a right triangle with hypotenuse 1, and the one side is going to be cosine of theta, the other side is going to be sine of theta. All right. Okay, perfect. Now what we are saying is my angle theta is 0. So you see this blue angle here, this one here, this blue angle here, it's 0. So it's 0. It means that, I mean, there's no angle. So it's like this blue side here, it coincides with the hypotenuse, right? They coincide because there's no angle. It's just the blue line. Sorry, yeah, the blue line or the blue segment coincide with the purple one, the hypotenuse. They coincide because the angle is 0, right? There's no angle, so it's just the same segment, right? So if they are the same segment, but I know, because that's by hypothesis, I know my hypotenuse is supposed to be equal to 1, right? The length of my hypotenuse is supposed to be equal to 1, right? So if my hypotenuse is equal to 1 and coincide with this blue line, then the length of this blue line is also 1.
I think we got it with another example, I guess, because this one.
But the thing is, so if they coincide, they have the same length, right? This blue side, and this purple, I mean the hypotenuse, they coincide, so they are the same, so they have the same length, and that will be so then the length of this adjacent side would be just 1.
So
But
I have a question. So if the hypotenuse was like 5, then the answer would be like 5.
no, that's the thing. Here we need to take a right triangle with hypotenuse equal to 1. That's really important. That's a very important hypothesis. We need, remember when we started our discussion, we said, because you see here, I said my cosine of theta is equal to x. The x here, this is supposed to be the length of the adjacent side. and we need the hypotenuse to be equal to 1. So we need to take a right triangle with the hypotenuse equal to 1. That's really important. Okay. Otherwise, it's not really the cosine. The adjacent side is not really exactly the cosine.
Professor,
Yes.
the hypotenuse over adjacent shouldn't that be the other way around? Because that's more of second.
You mean no, the definition of cosine? The cosine is supposed to be the adjacent side over the hypotenuse.
Yeah, but you have a hypotenuse over adjacent.
Hey, but that's the thing. The hypotenuse is 1, which means that cosine of theta is just equal to the adjacent side.
But that's a hypotenuse.
Yeah, because my hypotenuse is 1, so then cosine of theta is just equal to the adjacent side.
Yeah, but shouldn't the one be on the bottom?
Oh yeah, the one in the, of course. I mean, as you can see here, where is it?
If
Right
not,
here. Yeah,
second.
here.
Yeah.
Right here. The one is in the bottom here, the hypotenuse.
But on that example,
The right triangle.
yeah,
The hypotenuse is the side which is opposite to the right angle. You see here, there's this right angle here, this angle here, this 90 degrees. So by definition of the hypotenuse is supposed to be the side which is opposite to the right angle. So that's why this one here, this side here, that's my hypotenuse. It has to be my hypotenuse.
yeah. Now I know.
And all right, so once you get this cosine of angle 0 is 1, then well, you can use, for example, our trig identity. We said cosine square plus sine square equal to 1, right? So for example, then we can deduce. So now, using the trig identity, cosine square plus sine square equal to 1. So here the angle is 0, right? So we have like cosine of the angle 0 square plus like sine of the angle 0 square. That is supposed to be equal to 1, right? That's again because of the Pythagorean theorem. Now we are saying cosine of 0 is 1. So this is like 1 square here, right? Plus sine of the angle 0, square equals to 1. So there's 1 on the left, there's 1 on the right, as you can see here. So then sine of the angle 0 square, it's just 0. And of course, you take the square root, and then you take the square root here, take square root here. Well, plus or minus here doesn't matter because it's just 0. So then your sine of 0. So then sine of the angle 0 is just 0. So sine of the angle 0 is just 0. Okay, so you see, guys, if you get cosine, you can use it like a trig identity to, figure out the value of sine, for example. All right, so this is just like for the angle 0. You can take a different angle, of course. As I said, so we're gonna compute cosine and sine for some special angles between 0 and pi/2 or 0 and 90 degrees. So let me, well, here's an example of special angles. So what do I mean by special angles? Between 0 and pi/2 or 0 and 90 degrees.
So why did cosine 2 become 1?
Excuse me?
Why did cosine 2 become 1?
Uh,
Yes.
why the cosine of 0 is 1?
Yeah. No, no. I mean, you put 1, 2.
1, 2.
I mean, yeah.
Oh, no, that's the square. That's the square. 1
Yeah.
square. No, that's because of, we said this is Pythagorean theorem. And so now we have, because of the Pythagorean theorem, and when you apply Pythagorean theorem to our right triangle, where the hypotenuse is one side is sine and the other side is cosine. So then we said by Pythagorean theorem, cosine square plus sine square is
Yeah.
equal to 1.
Mhm.
All right. Now, what I'm saying is, if my angle theta is 0, right? So then that's like cosine of the angle 0 square plus sine of the angle 0 is square is equal. That will be equal to 1, right? That's what I'm saying here. Cosine of the angle 0 square plus sine of the angle 0 square, that's equal to 1, using our trig identity when the angle theta is 0.
So,
Now, what I'm saying here, 1 square, because cosine of 0, we just said, we just proved that cosine of 0 is 1, right?
yeah.
So this is just 1 square.
Mhm.
That's 1.
Mhm.
Okay, so the 1 square, it's 1, and there's the 1 on the right side, so they cancel out, right? You subtract 1 from
Oh.
both sides, right?
What? But the equal 1 is not squared.
Yeah, but the 1 square, it's 1 anyway,
Oh,
right? So okay, probably I jumped one step here, but what I'm saying is 1 square. So this is just 1 square, it's just 1. Okay, forget about that. This thing here. So what I'm saying is 1 square is 1 plus sine of the angle 0 square. That's equal to 1, right? And then what I'm saying is I'm gonna subtract 1 from both sides. Okay.
you subtract the
So-
1 from the right. I mean left.
If you subtract 1 from the left, you have to subtract 1 from the right, right? You have to
Right.
do the same thing on both sides, right?
Right algebra. Okay.
Yeah. So then you end up with the sine of the angle 0 square equal to 0.
Okay. Yeah. All right.
And then you take the square root.
Yeah. Okay.
Yeah, so examples, special angles between 0 and 90 degrees, or 0 and pi over 2. So special angles here, of course, we're gonna start with so we're gonna have this chart here. This is my angle theta. So special angle, we're gonna start with a 0 degree, or angle 0, and then after 0, we're gonna have just one problem about this. Yeah, one problem, one trig problem. Yeah, 0, and then pi over 6. So 0, that's 0 degree. Of course, this is 0 degree. Pi over 6, pi is 180. So this is 30 degrees. Next special angle, it's pi over 4, which is 180 over 4, which is 45. Right, this is 45 degrees. Don't be scared. I mean, it's not that bad. And then next angle would be pi over phi, which is 60 degrees. This is 60 degrees. All right, and then a last angle, I'm gonna take just pi over 2. As I said, just between 0 and pi over 2. So this is 90 degrees. Okay, now we are interested, of course, in cosine and sine of these angles. So we just proved, for example, so this is here, it's cosine of theta, and here it's sine of theta. Okay, so like when the angle theta is 0, we just proved that cosine of 0 is 1, right? So here, this is 1 here. Okay, so this one means cosine of 0 is 1. this is my angle, and this is my cosine, right? So cosine of 0 is 1. And we also prove that sine of 0 is 0. So here I'm gonna put 0. Okay, so sine of the angle 0 is 0. Now for 30 degrees or pi over 6. So the idea is the same. I mean, you take again. So the idea is to take, right triangle. Here the length is 1. This is your angle theta here. This is 30 degrees. All right, and this is 60 degrees. Okay, and what I claim is that if you take such a right triangle with hypotenuse equal to 1, with angles, so angle theta here, this is my theta, this is my angle theta, which is 30 degrees, and the opposite angle will be, of course, 60, right? Because remember, guys, the sum of the angles in the triangle, it's 180, right? So that's 30 plus 60 plus 90, that's 180, right? Anyway, so my point here, guys, is that, so if you measure this the length of this side here, that will be actually square root of 3 over 2, right? And if you measure the length of this side here, that will be half, 1/2. And actually, you can, if you take the square root of 3 over 2 square plus 1/2 square, that will be equal to 1 by Pythagorean theorem. And you can see it from, square root of 3 over 2 square, that will be 3 over 4 here, and half square, that will be 1/4. So that will be 4 over 4, and that will be equal to 1, right? Anyway, so what I'm saying here, guys, so what you have to keep in mind is that, so if my angle theta is 30 degrees, then cosine of 30 degrees would be equal to square root of 3 over 2. And this would be half. For pi over 4, you're gonna have both sides, they have the same length, right? So here it's going to be for pi over 4, so it's going to be square root of 2 over 2. And this is also square root of 2 over 2. Right? Because, I mean, if you have a right triangle and one angle is 45, the other angle has to be 45. Okay. And so this side here is going to be the length of this side here, this blue side here, is going to be equal to the length of this one here. Okay, because you're going to have the same angle, 45 degrees, right? For theta equal to 60 degrees, pi over 3, the cosine would be 1/2 here, and sine would be square root of 3 over 2. So as you can see, guys, here between 3 and 60, so if you compare here, this is 30 degrees and 60 degrees. So for 30 degrees, cosine is square root of 3 over 2. For 60 degrees, sine is square root of 3 over 2. Okay. For sine, for pi over 6 or 30 degrees, sine is half. Cosine of 60 degrees is half. Right. So we have the same values here. And last angle, 90 degrees. The cosine of 90 degrees is going to be 0. This is going to be 0. And sine of 90 degrees is going to be 1. So this is like, again, it's like for 0, cosine is 1, sine is 0. But for 90 degrees, it's like the opposite, right? Cosine is 0 and sine is 1. So this table actually is very important. We're going to use this table a lot because so the goal today is to to find cosine of and sine of like for any angle. Okay, so this is just like for some special angles, between 0 and 90 degrees. But the goal today is really to find, so what we're going to do today, and what's going to be in the final. We're going to try to find a cosine of theta and sine of theta for any angle theta, okay, using this table here. I'm going to show you how to find cosine and sine using this table. Yeah, Joel. All right. Okay, so I'm going to discuss first some properties of the cosine and sine. I mean, just from the definition, you can deduce these properties. So here's some properties of cosine and sine. Cosine, sine. So, for example, as we said yesterday, guys, the angle theta could be positive or negative, right? Depends on the rotation. If it's counterclockwise, then it's a positive angle. If it's a clockwise, then it's a negative angle, right? So the question, for example, is what's the relation between cosine of theta and cosine of minus theta, right? So let's see what happens to our unit circle. Right, so again, I have my unit circle. This is supposed to be my unit circle. Okay, so this is 1 here. All right. Anyway, so I'm going to take an angle theta, positive 1, right? So let's say from here to here. Okay, so this is my angle theta. Okay, so this angle theta is it's a positive angle, right? Because it's counterclockwise, right? Theta here is positive, so theta is positive. So theta, the angle theta here is positive. Okay, because it's a counterclockwise. Now I'm gonna take the minus theta. So what will be minus theta? Well, I'm gonna take the opposite rotation. So I'm gonna have like a clockwise rotation. So this is here, let's say here. Okay, clockwise rotation. So that would be a negative angle, right? Clockwise rotation, that would be a negative angle. So let's say this is the minus theta. Okay. So this is minus theta. Minus theta. All right. Again, guys, the difference between the two angles is that one is clockwise and the other one is counterclockwise, right? They're supposed to be the same angle. It's just they have different rotation, right? One clockwise and the other one is counterclockwise. Now, I want to compare the cosine of theta and cosine of minus theta. Compare cosine of theta to cosine of minus theta. So where is cosine of theta? Well, cosine of theta, as I said, guys, you take so the point which corresponds to the angle theta. So this is the point which corresponds to the angle theta, right? This point here corresponds to the angle theta. Now, the x coordinate of this point, that's my cosine of theta. So this point here, you see this point, this x here, this x, that's my cosine of theta. Okay. Remember, cosine, it's just you can think of the cosine as the x coordinate. Okay. Now, the other angle, the minus theta, what will be the x coordinate of the angle minus theta? Well, minus theta, so you have this point here. This point corresponds to minus theta, to the angle minus theta. right? And so the x coordinate of this point would be the same. Right? So what I'm saying is that these 2 points, they have the same x coordinate, right? So so these 2 points, so this one here and this one here, right, they have the same x coordinate, the same input x. Okay, same x coordinate. So if they have the same x coordinate, but x supposed to correspond to the cosine of the angle, so then cosine of theta is equal to cosine of minus theta. Okay, so the conclusion, so then cosine of theta.
That'll be pi over 4.
I mean, I didn't really take a like specific example. I mean, theta could be any angle.
All right.
It could be pi over 4, or but yes, I mean, if you yeah, yeah, it's a
It
the
was
angle theta
45
is like
degree.
yeah, like sort of 45-degree, yeah. But again, it's not. I mean, I'm not. You can just take any random angle. It doesn't have to be 45. I mean, this is actually true for any angle theta. It doesn't matter. So, for example, I can take like a larger angle. So, for example, let me show you something here. I can like do the same circle here, and I'm gonna take the angle theta like starting from this and going to this side here. So my angle theta would be like this one here. All right, this is my angle theta, and yeah, and then minus theta would be like you're gonna go like from this to this here. So as you can see, this angle would be. I mean, it seems like it's the same angle, but it's just they have different rotations, right? One clockwise, and this one here, this is counter. Sorry, this one here is clockwise. The yellow one is counterclockwise, right? So this one here is just minus theta. This is minus theta, right? But then the x coordinate, you can see the x coordinate here. Here's my x coordinate, and this point here, the x coordinate is the same. So they have the same cosine. These 2 angles, they have the same cosine. All right, so yeah, the conclusion, guys, that cosine of theta is equal to cosine of minus theta. And so cosine is actually an even function. This is very important. So cosine of minus theta. So remark. So if you take the function f of x equal to cosine of x, okay, and so what we are saying here is that cosine of x is equal to cosine of minus x. Okay? In other words, f of x is equal to f of minus x. And that's exactly the definition of even function, right? Even. So so cosine of x is an even function. So f of x, which is cosine of x, is an even function. Is even. So you see, this is an example which is not. I mean, this is not like some power of x. This is a different function, right? So this function is actually even. This cosine of x is even. Right. So this is very nice property, right? Now, what about sine? So you think of sine as the y coordinate of the point corresponding to the angle. Draw the angles. Well, yeah, probably you're gonna get partial credits. Yeah. Now, guys, for sine, same story. I have my unit circle. I'm gonna take some angle theta. Let's say I'm gonna take like this angle here. So here's my angle theta. It's positive. Now I'm gonna do the same here, like the same angle, but like different rotation, right? So I'm gonna go like clockwise. Oops. Well, I mean, my circle is not, it looks really bad, but okay, so this is a minus theta. So now you think of, as I said, you think of sine of theta. So the point which corresponds to the angle theta is this one here. And the point which corresponds to the angle minus theta is this one right here. This point here. Okay, again, this is a unit circle, right? This is the unit circle. That's the circle of radius 1. Anyway, so my point here, guys, is that if you take the y coordinate, so the y coordinate of this point would be this one. So here's my y coordinate, and the y coordinate of the other point. Well, my circle is really bad, but the idea is that, so the y coordinate of this point, oops. So the y coordinate of this point would be somewhere here. Right. And so then the thing is, well, because my unit circle is really bad, but the thing is this this y coordinate, this one here, and this one, they're gonna be opposite. Like, let's say this is like, let's say this one, for example, is half. This one is gonna be like negative half, right? So it's like this distance here. You see this, the length of this segment here, this one. So it's gonna be the same. They're gonna have the same length with this one here. Okay, it's just because it doesn't look like they're gonna have the same length, but it's just because my circle is really bad, right? But of course, this y here is positive because it's above the x-axis, and this y here, y coordinate is gonna be negative because it's below the x-axis, right? So what we are saying is that sine of minus theta, sine of minus theta, right? This one here, this y here is going to be the opposite. So it's minus sine of the angle theta. So the opposite of sine of the angle theta. Okay, so sine of minus theta is equal minus sine of theta. And so sine is actually an odd function, right? So sine of minus x is equal to minus sine of x. So the conclusion is that, and we're gonna use this later to compute, you know, like the sine of or cosine of some negative angle. So conclusion. So sine of minus x is equal to minus sine of x. So f of x, which is the sine of x, is odd. Is an odd function. Okay. So so the first property of cosine and sine. So cosine is even function. Sine is an odd function. Next, we're gonna discuss when the sine and cosine are positive and when they are negative. So in which quadrant they're gonna be positive and in which quadrant they're gonna be negative, right? So so next, number 2, sine of cosine of theta and sine of theta. So again, guys, we have this unit circle. So we have like 4 quadrants. I have this unit circle here, right? And so as you can see in this unit circle, so we have like 4 quadrants, right? So this is, so here, this one is gonna be my first quadrant. All right, this is my like my second quadrant. And this is the third quadrant. And of course, this is the fourth quadrant. All right. Now, of course, as we discussed yesterday, so this is supposed to be like here, it's supposed to be like the angle 0. This is the angle 90 degrees. So that's pi over 2. So this is pi over 2 or 45 degrees. This is supposed to be 180. Sorry, what I'm saying. Sorry, 90 degrees. Sorry. This is 90 degrees, of course. And then this is 180, so that's pi. This is pi 180 degrees. And then this one here, this is supposed to be, 270 degrees, or this is a 3 pi over 2. Okay. And then when you do like a full rotation, then when you come back to this point here, that will be 360, right? Or 2 pi. Okay, so this is, again, this is full rotation. So when you do full rotation, that will be 360. Anyway, so the question is, when the cosine and sine are positive, and when are they negative? So let's start with the first quadrant. So if you have an angle in the first quadrant, so I have an angle theta here, right? This is my angle theta in the first quadrant. So the angle, as you can see here, my angle is between 0 and 90 degrees, or pi over 2. All right, that's the first quadrant. Now, what will be the sign of sine and cosine? Well, as I said, guys, think of cosine as the x coordinate and of the sine as the y coordinate. So like this point here, the x coordinate would be this, and the y coordinate would be this one here, right? So is x and y, are they positive or negative? Well, I mean, this is supposed to be like my
Should be
x-axis.
positive.
Yeah, both of them are positive, right? And this is, of course, 0, yeah, so x and y, both of them are positive, right? So which means that the sine and cosine is going to be positive in the first quadrant.
Right.
So sine, so in the first quadrant, let me just probably make a table here. So first quadrant. So what we are saying is that cosine is positive and sine is also positive. Okay, now next quadrant, second quadrant. We're gonna take an angle in the second quadrant. So let's say you're gonna take the angle. Let's pick a different color. Let's pick this one here. Okay, so I'm gonna take this angle. So it starts from here and goes to somewhere right here. Okay, so this is like my angle theta. So it's in the, as you can see, the corresponding point is in the here. It's in the second quadrant. Right. What's the question, Sean?
Oh, sorry.
Oh, okay.
No, it's just
Oh yeah. That's the. Oh, I know. That's the. Yeah, all the students say. Well, actually, that's really, but probably not a good idea a bad way to memorize. as I said, actually, the best way is just to think of cosine as x, sine as y. So like here, the x coordinate is here, right? And x coordinate would be negative here. So then cosine is going to be negative. And the y coordinate, it's positive. So then sine is going to be positive. So yeah, so then so cosine is negative in the second quadrant because just x is going to be negative in the second quadrant. And y is going to be positive in the second quadrant. So that's sine is positive. Okay. So third quadrant. And after that, of course, fourth quadrant. Now, then third quadrant, if you take a point, I mean, just take a point. I mean, like a point here, the x is still negative and the y is also negative, right? So then both cosine and sine are negative in the third quadrant. So here cosine is negative and sine is negative. Fourth quadrant, if you take a point in the fourth quadrant, so for example here, I'm going to take this point, the x coordinate is positive, the y coordinate is negative. So then cosine is positive and sine is negative. Okay, so again, just think of cosine as x and sine as y coordinate. All right. Any question, guys? So that's for the sine. Right now, next and the last property is the so property number 3. And then after that, guys, I'm going to show you how to compute, the angles of, cosine and sine of any angle in general. So last property, which is a kind of very important property of cosine and sine, which is called the periodicity of sine and cosine. So what do I mean by periodicity of sine and cosine? Well, it's actually very simple. Again, I'm going to take my unit circle. Is my unit circle. It's not really, it doesn't look really good, but anyway, it's not really important. Now I'm going to take some angle theta. Okay, so here's my angle theta. This is my angle theta. Okay, this is my angle theta. All right. Now what I'm going to do, guys, so I'm going to do like a full rotation. So I'm going to do like theta plus, so theta plus 360 degrees. Okay, so that's or theta plus 2 pi. Okay, so that's like a theta plus a full rotation. So what do I mean is the following. So we start from here, okay, and then of course this is angle theta, the red the green one, that's the angle theta. Now what I'm gonna do, I'm gonna do like so I'm start from the same side here. So I'm gonna do like theta, that's theta, right? And then I'm gonna do another 2 pi or full rotation, right? Another full rotation, like a 360 degrees, a full rotation. And so when you do full rotation, you're gonna come back to the same side here. All right, so this is like theta, this is my theta plus a full rotation. So you're gonna come back to the same position here, right here, same place. Okay, so this would be theta plus, this is what I mean by theta plus 360 or theta plus 2 pi. Okay, so it's like theta and then you do like one full rotation, right? you can do like theta plus 2 full rotations, right? So you can do like you start from here. This is my theta, and then I'm gonna do 1 full rotation. All right. Come back to the same place, and then I'm gonna do another full rotation, right? So another one, and of course I'm gonna come back to the same place. Okay, so that will be like theta plus 2 times full rotations, right? So it's 2 times 360 degrees, or this is like theta plus 2 times 2 pi. So that's theta plus 2 full rotations.
It didn't.
Okay.
Oh, did you do it 3 times?
Excuse me?
Did what?
He just went up to the angle.
Yeah, to the angle, yeah.
Like he passed 360 and he kept going to the angle.
So isn't that? Oh, you only. Oh, you're not counting the blue one. Okay.
No, I'm not counting the blue one. That the blue one, that would be the theta plus 2 pi. The blue one, that's theta plus 2 pi. That's yeah. But my point here, guys, is that when you do like, so we have an angle theta, and then when you do like a full rotation, you're gonna come back to the same place, right, or same side, or the same point, right? And so if you come back to the same point, then the cosine and the sine, they're gonna be the same, because you're gonna still have the same x coordinate and y coordinate, because you come back to the same side or the same point, right? So so the conclusion here is that cosine of theta is the same as cosine of theta plus 1 full rotation, okay, plus, let's say 2 pi or 360. That's the same thing, right? Because as you can see here, for the angle theta, the green one, so this point corresponds to the angle theta, right? Now for the blue one, that's theta plus a full rotation. The theta plus 2 pi or theta plus 360 corresponds to the same point. So it corresponds to this point again, right? Because you come back to the same place, right? So it's the same point.
So is that the same as full rotation?
Yeah, it's the same as the full rotation. Yeah.
Mhm.
So what we are saying here, guys, is that if you have your theta and you add like 2 full rotations or 3 full rotations, or etc., that doesn't change the value of cosine or sine, because you're going to come back to the same place, or same, you're going to come back to the same point. So we're going to have the same x coordinate and the same y coordinate. So like this cosine of theta plus 2 pi is the same as, this is also equal to the cosine of theta plus twice or 2 times 360. That's the same thing as cosine of theta plus.
But that would only work with those conditions you give us, right? Like if it's outside of that and it lands in a different quadrant, then that would change the.
Oh yeah, of course. Oh, I'm saying you end up with the same quadrant, of course. Yeah, of course. You so
I
what I'm
get it.
saying is that, yeah, so it's like, okay, probably
Yeah, what I'm saying is like it only works that way with those
so
with those
it's
4
like,
that you mentioned up there. Like out of that, it would probably land on a different quadrant. And
yeah, of course, yeah. So for example, yeah, so like what I'm saying, so this is like my angle theta, and then what I'm gonna do like again theta plus, I'm gonna do like a full rotation, right? Come back to the same place, same side. So that's like my theta plus 360 or 2 pi, right? So you come back to the same ending or terminal side. And but it doesn't matter in which quadrant, of course. I mean, it doesn't really matter. I mean, it just you can take any angle theta. And if you do like theta plus 2 full rotations, so there'll be like so this would be like theta here plus 1 full rotation. You come back to the same terminal side, and then you can add another full rotation, right? And then you come back to the same place, right? That would be like, this would be like theta plus 2 times 4 rotations. Okay, but when you do a full rotation, it doesn't change the value of your cosine and sine because you're gonna end up in the same place or the same side. The same for sine, of course. So sine of theta would be the same as sine of theta plus 1 full rotation. So that's 2 pi, or sine of theta, that would be also same as sine of theta plus 2 full rotations. Or that's the same as sine of theta plus 3 full rotations, etc. Okay, so it's the same as you're going to have the same sign for any theta plus any multiple of 360 or any multiple of 2 pi. So yeah, so the conclusion is that, so that's what I call periodicity of sine and cosine. So you're gonna get the same value over and over again whenever you add like a full rotation. So cosine of theta is equal to cosine of theta plus any multiple, so k times the any multiple of 360 or 2 pi. So k, of course, k is just some positive, some integer. So same for sine of theta, that's equal to sine of theta plus any multiple of 360. So where k here, of course, is an integer. K is just an integer. For example, k is 1, that will be like 1 full rotation. K is 2, that will be like 2 full rotations, okay, etc. K is just the number of full rotations. So k here is just that's the number of full rotations. Okay. All right, guys. So this is like the main properties of sine and cosine. So now you know that cosine is even, a sine is odd. You know when the sine is positive, when the cosine sine is negative. Same for cosine, and you know that sine and the value of sine and cosine, it doesn't change when you add like any multiple of a full rotation. All right, so next, guys, I'm gonna show you how to compute the sine and cosine for like special angles between 90 degrees and 360. So between 0 and 90 degrees, we have the table. We have this table with the values of sine and cosine. Remember this table here. Where is it? Right here. So this is for special angles between 0 and 90 degrees, right? Now I'm going to show you how to compute sine and cosine for angles between 90 degrees and 360. And then I'm going to explain how to find cosine and sine for any angle. So this is next. So we're going to try to find next. So I'm going to find sine and cosine, sine and cosine of special angles between pi over 2 and 2 pi. So pi over 2 and 2 pi, that's 90 degrees and 360 degrees, right? Okay, so for this, guys, we're gonna use what we call the reference angle. So we're gonna have like 3 cases. So it depends on which quadrant we are. So if we are in the second quadrant, so let's say you have the angle theta. So let's say theta is an angle. Okay. So let's say first case, theta is in the second quadrant. Okay, so that's between 90 degrees and 180. Okay. And let's say you want to find cosine of for example, I want to find cosine of 120 degrees. Okay. Or I mean, cosine of 120 degrees, right? This is in the second quadrant. So there are 2 steps, guys. So first step, to find cosine of 120 degrees. So the first step, so step 1, so we're gonna use the reference angle. So use what I call, so we need to find what I call reference angle. Reference angle, let's call this reference angle theta prime. Okay. So theta prime, this reference angle, so the formula for this reference angle theta prime, so theta prime is actually equal to pi minus theta. Okay, so when we are in the second quadrant, so in the this is in the second quadrant. Okay. So for example here, my angle theta is 120 degrees, right? So theta is 120. Now, it doesn't make it negative because pi is 180. So then reference angle theta prime. So then the reference angle.
But the sign on the second quadrant wouldn't be negative.
The sign of what? You mean the sign of a cosine? Yes, you mean the answer is going to be negative.
Yeah, that's what.
Yeah. So the answer. I thought you were talking about the reference angle. Yeah, the answer is going to be negative. Yes, you're right. Absolutely. But first, you need to find this reference angle. So this reference angle, it's just some angle between. So the reference angle is always an angle between 0 and 90 degrees. So this is, let me write it down here. So theta prime, this is always between 0 and 90 degrees. Between 0 and 90 degrees. Or 0 and pi over 2. So like here in this case, theta prime supposed to be, as I said, in the second quadrant, supposed to be pi, which is 180 degrees, minus my angle theta. My angle theta is 120, right? And that's equal to 60 degrees. Okay. Or, I mean, if you prefer use radians, that will be pi over 3. So as you can see, guys, your reference angle is an angle between 0 and 90 degrees. And we know how to find sine and cosine, I mean, special angles between 0 and 90 degrees. We can use a table. So now in the step number 2, so in the step number 2,
Is that a 1? Is that theta raised to the power of 1?
Power 1. Where is that?
Exceed of 1?
Oh, prime. This is like prime.
No.
That's theta prime. That's like it's not 1. It's like a diagonal.
What do you mean?
It's not. So this is like a sort of like it's a line, but it's like it's like a diagonal. It's not 1.
Purpose is to make it a little harder.
No,
I mean, I don't see any other purpose.
but I mean, that's what I mean, that's the like the notation in the textbook for the reference angle. Just to make difference, I mean, you need to distinguish between theta, your angle. Yeah, it's like a dash, yeah, and your reference angle, theta prime. And then, so once you get your reference angle, which is an angle between 0 and 90 degrees, now you can use your table and find, use table, okay. And so then cosine of 120 degrees, okay, so that will be cosine of the reference angle, okay. But we need to adjust the sign, guys, here. As you said, cosine in the second quadrant, we are in the second quadrant, then cosine is supposed to be negative, right? So here we need the minus because we are in the second quadrant. So cosine is negative in the second quadrant. So then there'll be minus cosine reference angle. We said it's pi over 3. And what's the cosine of pi over 3? Well, here you check the table. So in here, you check the table. You know, we have this table with the cosine and sine for angles between 0 and 90 degrees. And so if you
60.
check cosine of pi over 3 or cosine of 60.
1/2.
1/2, yes, absolutely. So let me just show you guys. So here you go to this table. Where is it? Come on, here, yeah. So here's my pi over 3. That's my reference angle. And I'm interested in cosine. So cosine of pi over 3 would be this half here. Okay, so that's, so the answer here with the minus sign, the answer would be negative half. So here, so we have this minus, of course. I'm gonna put minus cosine of pi over 3 using the table. That's half. Okay, so the answer is negative half. Okay. So what we're gonna do, guys? This is like whenever you want to find the cosine or sine of any angle between 90 and 360, you have to use this reference angle. But actually, the formula of the reference angle depends on the quadrant. So in the second quadrant, reference angle is pi minus theta. Now in the third quadrant, so let me here. So this is the formula for the reference angle. Formula for reference angle. Angle theta prime. Okay, so it depends on, as I said, depends on the quadrant. Between, so this is, of course, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then you have 2 pi. All right, so between 0 and pi over 2, we use the table. So here, just use the table. Between, in the second quadrant, reference angle theta prime is going to be equal to pi minus theta. And again, the idea, guys, is that your reference angle is going to be an angle between 0 and pi over 2. So because theta is less than pi, you are in the second quadrant. So theta is less than pi, less than 180. So when you do pi minus your angle, so you're gonna get something which is less than 90 degrees. Now, for example, in the third quadrant, the reference angle is gonna be the opposite. So theta prime here, the reference angle is gonna be theta minus pi, because here in the third quadrant, theta would be larger than pi or larger than 180, right? You are in the third quadrant, it means that you are between 180 and 270, right? So we are larger than 180. So that's why we subtract pi here. So when you subtract pi, you're gonna get something which is between 0 and 90. And finally, if you are in the fourth quadrant, the reference angle theta prime would be 2 pi minus theta. Okay. So let me show you some couple examples now. How to use this reference angle, like in the third and fourth quadrant. So example number 2. Example number 2. Let's say you want to find in third quadrant, you want to find sine of let's say 7 pi over 6. Okay. I mean 7 pi over 6. This is just in degrees. That will be 210 degrees. Right? Pi is 180. So we are in the between 180 and 270. So this is in the third. Of course, this is in the third quadrant. Okay, so I want to find the sine of 7 pi over 6. I know it's in the third quadrant. So step 1, first I'm gonna find my reference angle. That's always the first step. Find reference angle. Theta prime. Okay, so what's theta prime? In the third quadrant, theta prime is theta minus pi. Theta minus pi. Theta is 7 pi over 6 or 210. I mean, it depends on you. I mean, you can use degrees, guys, or radians. It's up to you. But let's say you want to use radians. Okay. Because here the question is the angle is in radians, right? 7 pi over 6. So theta is my angle, which is 7 pi over 6. So this is like 7 pi over 6 minus pi. Again, guys, I got this formula here, theta minus pi, because we are in the third quadrant, so we have to use this formula, this one here. 7 pi over 6 minus pi. Of course, you need the common denominator. That's a minus 6 pi over 6. So that would be equal to 1 pi over 6. So my reference angle, so then theta prime, that's just 1 pi over 6. Okay. Or if you prefer that, this is 30 degrees. Okay, so I got my reference angle. Now I can compute step 2. I can compute my sine. So then sine of 7 pi over 6 is just equal to, well, sine of the reference angle. Reference angle. Okay, but then you have to adjust the sign, guys. So we are in the third quadrant, and in the third quadrant, sign is negative. So here we need a minus. So here we need a minus because sign is negative in the third quadrant. So that will be equal to minus sine. What's my reference angle? My reference angle is pi over 6 or 30 degrees. So now I check my table. And if you check your table, sine of pi over 6, if you check your table, that will be half. So this is equal to negative 1/2. Okay. Let me do one more example. Is there any question, guys? All right. So example number 3.
I don't know what
Yes.
to ask.
I guess this is going to the test. It's not even a question.
Yeah, the answer is, of course, the answer here is negative half, right? This is the answer here. So, I guess you're gonna need the table and you're gonna need this reference, the formula for the reference angle. For if you are in the fourth quadrant, example number 3, you are in the fourth quadrant. Example number 3. So let's say you want to find cosine of. You are in the fourth quadrant. So let's say you want to find cosine of. Let's see. Well, if you use if you want to use, let's use radians instead of degrees. So for example, you want to find cosine of let's see 315 degrees. Okay, if you want to use degrees. Okay. Okay. So or I mean, if you want to use the radians, of course, I think this is, so this is going to be, so 3 pi over 2, that'd be 7 pi over 4. Okay. I mean, anyway. So you want to find cosine of 315 degrees or 7 pi over 4, right? So this is, well, 315 degrees, of course, this is in the fourth, you are in the fourth quadrant. All right, this is in the fourth quadrant. Right. So you are in the fourth quadrant. Then first, step 1, use the reference angle. Step 1, find the reference angle. Find the reference angle theta prime. Theta prime. So because we are in the fourth quadrant, the formula for the reference angle is different. So we are in the fourth quadrant. So then the formula would be this one here. My reference angle would be 2 pi minus theta. Okay. So theta prime, or so the reference angle theta prime. So theta prime is going to be 2 pi or 360. I mean, or, well, let's do 360 here. For example, 360 minus 350. If you prefer radians, that will be 2 pi minus 7 pi over 4. All right. Anyway, so then the answer, of course, here would be 45 degrees, which is, of course, pi over 4. Okay. So that's your reference angle. So you got your reference angle. And then and next step, step number 2. Okay, so we're going to compute this cosine of 315. Okay, so we said should be cosine of reference angle, but you need to adjust the sign. So we are in the fourth quadrant and cosine is positive in the fourth quadrant. So here we're going to have a plus. Okay, this is because cosine is positive in the fourth quadrant, right? So we're going to have a plus. So plus cosine of the reference angle, which is 2 pi minus 7 pi over 4, which is cosine of, which is 45 degrees or pi over 4. So this is plus cosine of 45 degrees or pi over 4. And then if you check the table, guys, so this is equal to, so here, check the table. Cosine of 45 is just square root of 2 over 2. So this is, so plus square root of 2 over 2. And that'll be the answer. Okay. So that's how it works in general. So if you have an angle between 90 and 360, you have to, and you want to find some sine or cosine, you need to find your reference angle first. And again, the formula of the reference angle depends on the quadrant. And then you have to adjust the sign and then use your table. Okay. Right, so here's an exercise good for you guys. And before the break,
What's the formula for quadrant?
the reference angle here.
No, for 1 and 4. I only know the ones for 3 and 2 and 3.
Oh, here, right here. It's this one here, 2 pi minus theta. Right here. That's 360 minus your angle.
And what about quadrant 1?
Quadrant 1, there's no,
Oh.
you see here, quadrant 1, I'm gonna just use the table, right? Because
Oh.
we have the table for the cosine and sine for special angles between, 0 and 90 degrees. That's like your first quadrant.
Okay.
You have the table for that.
Okay. Mhm.
Yeah, there's no reference angle for between on the first quadrant.
Okay.
Yeah. And then of course you need to know the sign, if sine is positive or negative in your, or cosine is if it's positive or negative in the given quadrant. All right, so here's an exercise for you guys. 2, 3, 4. So we need to find. All right, so sine of let's say this is a 3 pi over 4. Right. This is sine of say a 5 pi over 3. Okay. Cosine of 4 pi over 3. Okay, and then cosine, let's say cosine of 11 pi over 6. Yes. So this is kind of well, I mean, after the break, I'm gonna show you how. So this is like for the angles, this is like for the angles between like 0 and 360, right? But then I'm gonna show you like in general, like for any angle, because the angle theta could be any number actually. It doesn't have to be like between 0 and 360. It could be 1000, or it could be any number, right? So I'm gonna show you. It's not really hard, but I'm gonna show you later after the break how to compute the sine and cosine
So
of yes.
what I'm saying, like so far, this is the first
Yes,
problem that we're gonna have on the
yeah,
test.
yeah, yeah. Yeah. Yeah, this is in the final tomorrow.
Do we convert those to degrees first, right?
I mean, it's up to you, because I mean, if you prefer degrees, yes, yes, it's up to you. I mean, you can use radians or degrees. Yeah, probably. I mean, you want to first figure out if in which quadrant is the angle, right? Yeah, I mean, of course, pi is 180 degrees, right? So you can.
Do we have to do the whole process of finding the? I mean, like, do we have to put it all? Like how we
Yeah,
do
the work.
to get the reference angle? I
Yes,
mean, I
please.
guess that's the
Yes.
point. All right.
Yeah, that's the point. Yeah, that's the point actually. Yeah. You got square root of 2/2, Elizabeth, for number one. Yes, that's very good. That's, yeah, correct.
Um, you said we could just leave the answer as degrees, right?
Yeah, yeah, it's up to you. Yeah, if you're, um, I mean, if you have trouble with the radians, yeah, use just the degrees. Elizabeth, number two, minus square root of p over 2. Let me see. So this is, yes, so this is, yes, very good, Elizabeth. Yeah, absolutely. Yeah.
That'll be 135.
Lorden, that's, yes, for number one. Yes, square root of 2 over 2. Yeah. Uh, Tiffany, you're saying 2 over 4? For I guess I don't understand your answer. Oh, 2 over square root. Yeah, square root of 2. Yes. Mm-hmm. Yeah. Yeah. Absolutely. Yeah. Lorden, is that your answer for number 1 or number 3? I guess. No, not number 3. Number 2 or let's see, number 2. Nope. Why did you get this square root of 2 over 2? I mean, square root of 2 over 2. That's when you have when you have the 45 degrees, right? Pi over 4. But for number 2, the reference angle, it's not pi over 4 for sure. 5 over 4. Oh, you did 5 over 4. Oh, okay, that makes sense. Yeah, no, it makes a huge difference. No problem. Sure. Yeah. Do you want to take a break now, guys? And then after the break, I will go over this, or you want me to go over this now and then take a break? Probably after the break, I guess.
Yeah, after the
Yeah.
break.
Let's
Finish it, 'cause I'm not done.
Okay, no problem. Okay,
Okay.
let's then take a break 10 minutes, and then after the break, I will go over this, and then we're gonna finish this section. Right. Okay, I'll be back at 8:11. Lord, number 3 is -half. Yes, very good. That's very good. Yeah. So I'll be back at 8:11, guys, or 12. Let's be precise. At 12. Okay. All right.